In the last section, we learned how to divide polynomials. Dividing polynomials allowed us to simplify general polynomials. And we saw that if we divided a polynomial by a certain term and the resulting remainder was 0, then that term was a factor of our polynomial. At times, it's convenient to check to see if a term is a factor of a polynomial, but it takes a long time sometimes to actually divide polynomials. So we want to come up with a shortcut. And we're going to do that through the following two theorems, the remainder theorem and the factor theorem. The remainder theorem states the following. If a polynomial f of x is divided by the term x minus k, then the remainder of the division is the value f evaluated at k. And one version of the factor theorem states the following. X minus k is a factor of the polynomial f of x if and only if f evaluated at k is equal to 0. Let's go ahead and practice using these theorems. First, let's find the remainder of f of x divided by the term x plus 3. Now, since we're given x plus 3, our k in this case is going to be equal to a negative 3. And recall, by the remainder theorem, the remainder is given by f evaluated at k, which is equal to f evaluated at negative 3. Plugging this in, this is going to be equal to 2 times a negative 3 raised to the 5th, minus 3 times a negative 3 raised to the 4th, minus 9 times negative 3 raised to the 3rd, plus 8 times a negative 3 raised to the 2nd, plus 2. This is equal to 486 minus 243 plus 72 plus 2, which is equal to 806. Whoops, there's a simplification error here. Instead of 486, there should be a negative 486 minus a 243, which comes from this term, plus a 243, which comes from this term, plus 72 plus 2, which simplifies to be equal to a negative 412. Now, we're going to determine if x minus 2 is a factor of x cubed plus 4x squared minus 4x minus 16. To do this, we're going to use both the factor theorem and the remainder theorem. So the factor theorem states that x minus 2 is a factor if and only if we have that k is a 0 of f of x. And to evaluate the remainder, we're going to apply the remainder theorem to this term here. So evaluating f at 2, this is going to be equal to a 2 raised to the 3rd plus 4 times 2 raised to the 2nd minus 4 times 2 minus 16. Simplifying this, our first term becomes an 8, our second term becomes a 16, minus 8 minus 16, which is equal to 0. So what this tells us is that x minus 2 is a factor of our polynomial x cubed plus 4x squared minus 4x minus 16.